Good. So what I've done, I'm kind of learning how to write code in assembly language. So I wrote a very basic picture viewer. It displays Koalapic format pictures. I've written it in assembly language for the Commodore 64. I'm eventually going to be adding more features for it. It's pretty basic right now. I'm also going to go over how you can get really nice looking pictures off the internet or off a digital camera and convert them into Koalapic format to be displayed on a C64. At the end of all that, I'm going to be showing off my 128 that has an embedded micro IEC controller in it, so I can use SD cards instead of floppy disks. So I've got a nice little PowerPoint presentation here. If some of my code looks sloppy, it's because I'm still learning. You will see some commented code in here that's not like it's commented out, but there's no explanation as to why it's there. That's because I used the file that I hadn't cleaned up to do my screenshots with before I got everything ready for the presentation. So the purpose of me doing this is, first of all, I wanted to learn how to write something I could use in assembly language. A picture viewer is a useful tool. It's something that can be built upon, or what I've written to display the picture could actually use it in a different program. I wanted to be able to build something that I could expand on easily with new features. And if anybody's interested, I have the source code available. I can email it to you or whatever. It's pretty well commented. And I'm going to go over some of the source code that I've written. Some of the code that you'll see here is being borrowed from Codebase 64. Some of it is being rewritten by me. The file name input, string input routine is pretty much word for word copied from it. I've given credit in the comments in the program. I just needed a quick and easy way to actually be able to input a string. So the tools that I use to do this under Windows would be Notepad to write my code in, and Acme, just the command line. It's a command line assembler. It's free. I can provide the URL to download it. For testing, I use WinVice. Moving the files from a PC to a CBM, I either copy it right to an SD card, place the SD card in my 128, and load the file and display the pictures right off the card. I've also injected them into a D81 disk image and used it within the emulator or on a real C64. To convert the pictures, there's dozens of programs available on the internet that can resample and scale images. The one I chose to use is Commodore Pro because I've been using it for years. It's not a free program. To convert the JPEG file format pictures to Koalapic, I made a program called GangEd, which is free. And it will take the picture and remap it into the right color space and resize it and stuff like that. And that was not supposed to happen. Okay, let's try this again. There we go. So what the program does is basically a rundown of what the main loop of the program does. It loads a disk directory from disk, it parses it and displays the file names on the screen. Then it waits for your input with the keyboard to type in a file name. It loads the file to a specific memory address. It initializes a multicolored bitmap screen. Moves the file contents to the appropriate areas of memory, like what's being loaded in off the disk. Waits for the user to press space and then starts from the beginning. This is what the code for the main loop looks like. Basically, it's just a bunch of calls to different routines. The first line clears all the input channels. That can probably be removed from the program because I was doing that to troubleshoot a problem with it. I have a couple calls to routines that just print stuff on the screen, like this prints the title. That's a little routine I wrote to do that. This prints the enter file name prompt, and so on. The third line actually calls the function to read the disk directory. It reloads it to 1000, prints the contents of 1000 to the screen, prints 2 character returns. Then it displays your enter file name prompt. And where that leaves you in the program right here. So by the time it gets to that point, this is all equal. So after that, it calls a routine to input the text. Clears the screen, loads a picture from disk. Okay. Have I lost everybody? Or is this? Okay, good. Okay, this is where a very simple error handling routine. I store the when I finish loading the file, it stores the results of the load to this address here, C000. I'm not using it for anything else. Compares it against form, which is file not found. Okay, that when you call load, the kernel routine load, if it is successful, it returns 0. If it's unsuccessful, it returns an error code. And that error code is left in the accumulator, the processor. So I store that in C000. If the contents of X are equal to 4, which would be what was returned in the file not found, it skips to here, which basically resets everything with screen colors and so on, clears the screen, and jumps back to the top. If it's successful, it turns the screen and border colors black. DO20 is back to the VIC2. It's the VIC2 register for the border. DO21 is background. It jumps to routine to change the display mode to multicolor bitmap. Then it copies the image to image to all the appropriate places in memory. Then it waits for the space bar. Then it sets it back to text mode, and then it goes back through this start, rereads the disk directory, and prompts you for the next picture. So, Koalapic format, a picture is just a linear file with bytes. And so from byte 0 to 1F, 3F is the bitmap. 1F40 to 2327, these are all in hex. That's the screen RAM. 2328 to 27, or 270F is color RAM, and 2710 is the background color. And normally, the file is loaded to memory address 6000, which is exactly what I do in my program too. Loading the disk directory, all the kernel routine, it uses kernel routines for all input from the disk drive. Basically, the program will pull in bytes from the disk drive, discards the first entire line of the directory. Then it will start with the next line, and it will discard all bytes until it reaches a quote. Starts copying those bytes to 1000 plus n until the next quote is reached, which would be the end of the file name. Continues reading and discarding bytes until the end of the line. It sticks 0D as the file name delimiter. I could have used pretty much anything for that, but I could have even left it as is, put 00 or 99 or something like that. 00 is something that should never appear in a file name, which is the equivalent of a carriage return. So that's why I did that. And then it continues doing this until it either gets an error or reaches the end of the file. And this is what the code looks like. So first it loads below on the high byte of the directory name into X and Y. It loads the length of the file name, which is 1 byte, into the accumulator. It jumps to a routine that sets the file name, sets it as file number 2. That's supposed to load the last used device. For some reason, in the emulator I was using, that didn't work, so I actually load, which is this, drive 8, secondary address 0. I jump to this routine, then I jump to open. If open fails, it skips to error. In this, there's no error handling for the directory, so if loading the directory fails, I think the program crashes. Anyway, that'll be fixed. Now, this skips the first I think it's 38 bytes in the directory. That's hex 20. I can't remember what hex 20 converts to.
It's 32.
32. Then it jumps to the next version. This gets the whole first line of the directory. Then it jumps to get byte, which reads the next byte in, decreases y, and then skips back, branches back until the y registers 0. So for the next line, this is the next part of it. We'll start reading the starting bytes until it reaches a quote, which is hex 22. Once it reaches that point, it continues getting byte, compares it against quote. If it's equal, it jumps to this here, which is the end, the function that will read all the bytes until the end of the line. If not, it jumps to a routine to store the value that's in the accumulator into the memory starting at 1000. Then it jumps back to full 2. So we'll just continue with the next paragraph until it reaches the quote, and then it reaches it. End line, it just reads bytes until it reaches null, which is the end line. Then it loads 0D into the accumulator.
13. That's 13.
Sorry?
13, which is a carriage.
13 in hex, yeah.
Well, yes, the ASCII.
Oh, sorry, in ASCII, yeah. Stores that into the memory of 1000 in between columns. Gets the next byte. So the error was here. That's not true. So at the end of it, this is where it's getting comments. Oh, it's loading FF to the accumulator and storing it at the end of where all the file names are stored. So that's how it determines the appreciated copies is value of FF. Get byte. This is borrowed from, some of this is borrowed from OP60. This is a routine just to store it in memory. It loads 0 into y. It loads the value at f0, comma y. So y stays 0. This actually would be the address that's stored. I store an address at f0. So if the address would be 1000, and f0 would be 00, f1 would be 10. They have to be reversed that way. So when it loads this, it's actually loading 1000. So it's going to, sorry, when it loads there, when it looks at this address, it's 1000. Comma 1, so 1000, comma 0. It increases f0, so the first time through it would be 1000, 1001, 1002.
Okay, all right.
And so on. It loads f0. If the value of f0 is 0, then it branches. Sorry. If this is 0, then it will continue down and increases f1. So if your value is ff, so that would be 10 ff, the next time it goes through, it will increase the second 2 bytes. So your memory address will be 1100. Does that make sense? I'm not good at explaining. I explain these. Then if it ever reaches here, it returns back to the subroutine to continue doing what it was supposed to do. So displaying the file list, the size of the directory will be constant. It stores values 0, 0, and 01 to f0 and f1, which you've seen me kind of explained there. It uses that 0-page indirect addressing in a loop to print the file list to the screen using character out. As it's doing that, it replaces carriage return with space, because I ran into a problem where if I had too many file names on the screen, as soon as it started scrolling the screen, my screen would get buggered up. like the rightmost column would, or sorry, the leftmost column would jump over about 5 characters, and I couldn't figure out why that was happening, so I just put spaces in between the file names. Continues until FF is loaded into the accumulator. And this is what the code for that looks like. So it loads those 2 values into the Y. This shouldn't be here. I then stored it F0 and F1. I transfer A to X and A to Y. Clear out my other 2 registers, and then I load this would load the memory address, Y, compare it to 0D, branch not equal to next, so if it's not equal, it jumps down here. And carries on through the load. And each time it goes through, it increases the memory address by 1. Prints the next character out on the screen. The file name input routine. I found a robust string input routine on Codebase 64. Basically, when it gets a character, compares it against a list of allowed characters. If it's allowed, it stores it in the memory address, increases that pointer by 1. It handles delete, it echoes the output to the screen, and it uses 2 kernel routines to do that. So this is copied almost letter for letter from that website. And basically it I have all my variable definitions in the program. I don't think I copied it in this presentation. But load, it basically loads a high level memory address for text is. It stores a maximum number of characters, or it stores a value of Y, which is 38 into max characters. It stores the addresses. This actually, what they've done in this is they're overwriting the memory address. You'll see that a little later in the routine. This stores the memory address keys in a certain spot. If no characters are received, it stores that in Y. Then it waits for a character, so it jumps in the getting routine, and that comes back equal. It branches to the get input into the. If this comes back equal, it jumps back here and waits for the input routine to be called again until you get the keyboard. It stores the last character. It stores whatever's at A into the last character address. Compares it against the delete key. If it's equal to delete, then it jumps to a routine to handle deleting it. Otherwise, compares it against carriage return and branches to input done. And that's a routine that basically points to a series of bytes that you can define that will say which keys are allowed to be, or which letters or numbers or characters or symbols are allowed to be input. And I will copy that part of the story, or that part that I can open the source code and show it to you. So at the end of this is where that memory address for the text variable gets stored. Or sorry, where check allow gets stored. Compares it to the last character that's it. If it's equal, it branches to input OK. If not, it increases X, and then jumps back to check it out to get the next character. If input's OK, it loads the last character in the accumulator, loads input Y into the Y register, stores it, so this would be the character number, stores it into God input on the Y, and jumps the character out to print it on the screen. It increases the number of characters. At the end is reached, it loads this, there it loads the value of input Y to the accumulators, compares it to the next character, branches. If it's equal, it branches to input done. If not, it branches to the input get routine to read the next character. Input done. It loads the number of characters into Y, loads 0 into A, stores A into the dot input, comma Y, so that 0 terminates the string, stores Y to, I have an address specified for the length of the string, so that's the number of characters that have been successfully entered, and then returns back to the program. If it's a delete character, it loads the value of input 1 to the accumulator. If it's not, say if it doesn't match, it branches to delete OK. If it does, it just moves the pointer back by 1 value. Stores 0 over the last character. In case no other characters are entered, stores that into the dot input called Y, and then prints the delete character to clear that letter off the screen, and then jumps back to the input get view. So I have the program, it loads the file to 6000 using the kernel call to load and return 0 if the load is successful, otherwise it gives an error number on the accumulator. Program only cares about file not found error, which is 4, or hex 4, decimal 4, stores that value into the background color, so the screen turns purple if the file's not found, and into C000. C00 is checked later. If not 0, the program will branch around the picture display routine. So if there's ever an error, it won't try and display it on the screen. My first version of this program used a whole bunch of load address comma X and store address comma X, and I had to have, I think it was about 45 to 50 lines of code to copy all the data, because you could only do 256 bytes at a time. So I found this other routine that uses addresses in 0 page. You load the low byte and the high byte like I did with printing the string out, or loading in the file directory and stuff like that. There's 2 different versions of this routine, because you can write the code really simple if your memory addresses are multiple of 100. But if one of your memory addresses is a multiple of 100 and the other one is not, then you have to look at the low byte of both memory addresses and the high byte of both memory addresses, or else you'll miss pieces of what you're moving, which happened to me the first time I tried this. So this is a simple routine. So it loads 00 into memory address F7 and 60 into address F8. So that's memory address 6000. It loads 00 into F5 and 20 into F6, and so that's 2000. So I'm moving from 6000 to 2000. It loads what's found at 6000, comma Y. Y is always 0, so it always only looks right at that byte at whatever that memory address value is. Then it stores it. So it loads it from 6000, stores it at 2000. The next time